In this lesson, we'll be proving the sum to nth term of an arithmetic series. So now, suppose we have a series 1 plus 2 plus 3 plus 4. How many terms are here? Well, we have 4 terms. So now, what is the sum of all these terms? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. The sum is 10. Instead of doing these things manually, we can use a formula which can help us find the sum. It reads as follows. The sum to nth terms is equal to n over 2, 2a plus n minus 1 multiplied by the difference between terms. So now, what is s for? Because we are saying the sum to 4 terms. That is 4 over 2. That is open brackets. 2a is 1, which is the first term in the series, plus n, that is 4, the number of terms of the series, minus 1 multiplied by the difference. The difference to move from 1 to 2, it's 1. Difference, you just have to say t2 minus t1, t3 minus t2, and you'll get 1. Now, 4 over 2, that's 2. 2 times 1, that's 2. Plus 4 minus 1 times 1, that is 3. And then we have 2 multiplied by 5, and that gives us 10. You see, we get the same answer, either doing it manually or using formula. But we have a formula which can help us simplify things for us. This is the formula which we'll be using to find the sum to any terms in an arithmetic series. So, we are going to prove the formula. It's for exam purpose. You must know how to prove this formula. An examiner can say prove this formula either for 5 or 6 marks. So what we're going to do here is that the sum to n terms is equal to t1 plus t2 plus t3. There are other terms in between, plus tn, and tn is the last term, and this will be equation number 1. Or let's not say equation number 1 yet. We'll write equation number 1 on the second sentence. Okay, so Sn is equal to, what is T1? T1 is given by A. What is T2? T2 is given by A plus D. What is T3? T3 is given by A plus 2D. That's A plus 2D. And we have to put these things in between, then plus, then we say Tn. Then this is equation number 1. Now, to get the second equation, we simply have to write the first series in reverse. Meaning we have to write equation number 1 in reverse. What do we mean by that? Let's do it. Sn is equal to, this term we're going to start from the last going to the start. Meaning our first term will be Tn because we are starting from the last. This will be Tn plus. So here, let me illustrate how we are going to do it with an example. Let's do it like this. So suppose we have 1 plus 2 plus 3 plus 4 plus 5. If we are saying that the sum is equal to 1 plus 1 plus 1 plus 1 plus 2 plus 1 plus 3. That is A plus D, A plus 2D, and A plus 3D. If we are to start from the last, we are going to say that Sn is equal to, the first term will be 5. What is the second term? Second term is 4. What is 4 in terms of 5 and the difference? This will be 5 minus 1. This means this now becomes our first term. And now we are subtracting the difference from the first term. We are no longer adding the difference because we are going in a reverse order. I hope you understand this. So, we're going to do as I said here. So what we're going to say here is that we're going to say that the next term will be Tn minus D plus Tn minus 2D plus, and the first term will be A because A was the first term in the equation 1, but because we have started from the last going to the front to the start. Now this becomes the last term, and this will be A. And this is equation number 2. I hope you understand this. So here we're going to see equation number 1 plus equation number 2. What is equation number 1 plus equation number 2? We're going to say that equation number 1 plus equation number 2. What is Sn plus Sn? That gives us 2Sn. What is A plus Tn? That gives us A plus Tn. A plus Tn. Then let's see here. Let me use a different color. If we add the negative d and the positive d, note that they will cancel each other. This means that this one here will cancel this one. This one will cancel this one. And they will go further, the others here which will cancel each other. And at the end, we have A plus Tn, which is this A plus Tn, this A plus Tn, this A plus Tn, this Tn plus A. So we're going to do it this way. We're going to say that we have added the first A plus Tn, and you are also going to say A plus Tn again, and then plus the other A plus Tn, A plus Tn, and then we're going to leave others here, and then we write the last A plus Tn, A plus Tn. I hope you understand that. And what we're going to do here is that we're going to say that 2Sn is equal to, because we don't know how many A plus Tn's are there, we're just going to say n multiplied by A plus Tn. N stands for the number of A plus Tn's which are here. And we're going to divide both sides by 2. And we'll be left with Sn. And Sn is equal to n over 2 multiplied by A plus Tn. Because we are on an arithmetic sequence, do you still remember what we said about Tn? That Tn was equal to A plus n minus 1 multiplied by the difference. So when we see Tn, we are going to plug this. Let's write it. This means that Sn is equal to n over 2 multiplied by A plus, when we see Tn, we're going to plug A plus n minus 1 multiplied by D, and we're going to use square brackets to denote this instead of using the same round brackets. This means that Sn is equal to n over 2. What is A plus A? That's 2A plus n minus 1 multiplied by the difference. And this is the equation which we said we were proving in the first place. There it is there. I hope you can see it further. So now just follow the steps. Just know that to repeat all that I've been saying, we're going to say that sum to n terms is equal to the first term plus the second term plus the third term. They add each other up until the last term, which is denoted as Tn. Now Sn is equal to T1, we've said can be written as A, T2 can be written as A plus D, and T3 as A plus 2D. And at the end, we have equation number 1. In the second equation, we're going to repeat the first equation, but this time we are writing it in reverse, meaning the last term becomes the first term, and the first term becomes the last term. And because we are now writing in reverse, we are going to subtract the difference instead of adding the difference. This means that Sn is equal to Tn. You see, it was the last, but it became the first here. This was the first, but it became the last here. It shows that we've written our things in reverse. I hope you understand this. At the end, you add the two equations. the d cancels the d, the minus d, the 2d cancels the minus 2d. Somewhere we have 3d, which will cancel the negative 3d. Then they will cancel each other up until we add the last terms. And at the end, we have n number of a plus tn's. We do not know how many they are. So we just say n multiplied by a plus tn. And at the end, we are here now. We're going to plug tn. Tn is this thing over here. So we are going to plug it. Then you see, there it is. We've plugged it. Then a adds a, then we have 2a. Then at the end, this is the sum to n terms formula of an arithmetic sequence. You can use this formula to add any number of terms which you are being requested to add. There are two formulas which you can use. The other one, you can only use it if you know the last term, but this one works in all cases. So I can guarantee you and recommend you to use this formula only. Thank you for watching.